So today we are going to talk about the mechanism of adhesion. What is that process which help in binding the adhesive to the substrate, or what is the process, what is the mechanism which binds the two surfaces together when an adhesive is applied in between. So the adhesion can basically occur due to mechanical interaction or mechanical bonding, which basically involves the interlocking of the pores. It can also happen with the help of physical interaction, and in physical interaction, basically the van der Waals forces are the ones going to play the role. Or the adhesion can take place with the help of chemical interaction, which is the strongest, and a proper chemical bond formation take place. The adhesion can also be due to diffusion interaction or diffusion adhesion, which is very interesting and basically occurs by the diffusion happening across the adhesive and the substrate. Last of all, the adhesion mechanism can also be electrostatic adhesion, wherein the opposite charges are present on the surface of the glue and on the substrate, which actually binds them together. So this is an overview of the mechanism of adhesion. Let's discuss it in detail. To begin with, let's pick up the chemical interaction or the chemical adhesion. Now, the chemical interaction occurs between the target molecule, that is the substrate, and the adhesive. This chemical interaction, as you can see, the pink colored layer which is sandwiched between the two blocks over here is the layer of the adhesive. So a chemical interaction is happening between the adhesive molecules and the two surfaces which are sandwiching it. This leads to the formation of a chemical bond between the atoms, resulting in a relatively stronger adhesion. And this is also primary bonding force, or it is also known as the primary bonding force. Basically, it includes the hydrogen bonding and the covalent bonding. So since the covalent bond formation takes place and also the hydrogen bond formation takes place, so this is one of the strongest mechanism of adhesion. It is very difficult to split the two parts apart when such type of adhesion is taking place, with the bonds occurring between the functional groups. So basically it is the functional groups which are present in the adhesive and are responsible for binding the molecules for the formation of covalent bond between the two surfaces. And the functional groups in the adhesive and the atoms or the molecules which are present on the substrate surface, they combine together to form covalent bond or hydrogen bond formation might take place. This mechanism, basically, since it is a very strong force binding the two surfaces, so definitely the mechanism contributes to the structural strength of the many adhesives. So the adhesives wherein we want to impart the structural strength, we use such substances like the epoxies, which is used for bonding the aluminium frames or aluminium bars or aluminium surfaces. So the epoxies are having the functional groups which leads to the covalent bond formation or the hydrogen bond formation between the metal surfaces, so contributing towards the structural strength. Wherever we need the strong strength, a strong structure, we use such kind of adhesives. So that's the chemical interaction or chemical adhesion. So here you can see very well that the adhesive and substrate are having separate functional groups. There is a carbonyl functional group present on the substrate surface, whereas the adhesive is having the NH group. So a chemical bond formation between NH and CO takes place, resulting in the formation of a strong layer of adhesion between the two surfaces if the adhesive is in between, or let's say the adhesive gets sticked up to the substrate with the help of the chemical bond formation over here, and it is the functional groups present on the two surfaces which are responsible for such type of adhesion. Our next mechanism to study is the diffusion adhesion. Basically, what happens in this case, the diffusion occurs when the adhesive polymer is capable of penetrating and entangling with the polymeric substrate. You can see the pink colored adhesive molecules, they are penetrating the molecules of the substrate, which is black in color over here. So the polymeric molecules, they penetrate and entangle in the polymeric substrate, which leads to an interface creation with the entangled polymer chains bonding the adhesive and the substrate. So basically the bonding here is taking place due to the entanglement of the molecules, polymeric chains of the adhesive and with that of the polymeric substrate, because the substrate is also having polymeric chains here. So this mechanism is common in assemblies with difficult to bond low surface energy materials, the materials which have low surface energy like the polypropylene easily. So in that case we need to look for those adhesives which has the polymeric chains which can basically creep into the surface of the substrate, like polypropylene. This theory is applicable when both the coating and the adherent are polymers. Of course, they must have compatible long chain molecules, then only the creeping and the moving and the penetrating and the entanglement will take place. And so we have an example, a very good example of this type of diffusion can be seen the solvent cementing or the heat welding of thermoplastics. So the interdiffusion of the adhesive polymeric chains or molecules takes place into the polymeric molecules of the substrate. That's the diffusion adhesion. The diffusion interaction is actually a two-stage process. One is wetting, which is followed by interdiffusion of the chain segments across the interface to establish an entangled network of molecules. So for the diffusion to occur, the adherent and the adhesive, they both must be chemically compatible, which means that the materials must be mutually soluble and the diffusing molecules should be mobile. However, you can achieve the mobility if the material is sufficiently kept at high temperatures so that it can form a melt or dissolve in the solvent solution. Now, since it is relatively very uncommon for the adherent and the adhesive to be soluble in one another so that diffusion can take place, entanglement can take place, this theory can be applied only in the limited cases. For example, this theory can be applicable primarily to the solvent or the heat welding of the thermoplastic substrates. There you can find diffusion interaction, wherein the creeping of the polymer molecules and their entanglement together can be seen and plays a major role in adhesion process. Next, let's explore the mechanical bonding or the mechanical interlocking adhesion. This basically involves the two surfaces which get bonded with to each other by an adhesive which actually cures after filling the holes and asperities on the surface. So practically speaking, when you apply the adhesive on the surface of the substrate, the adhesive, since it is liquid and free flowing, so it flows easily into the little cracks or pores or pits or holes present on the surface of the substrate or the surfaces that you are trying to bond together to stick together. Then curing takes place and the two surfaces are sticking together now. So just because of this factor, this is also called as anchor effect or the fastener effect. The interlocking here provides the physical impediment to the crack propagation at the interface and increases the surface area. So that's the mechanical interlocking adhesion. Basically here what is happening, the adhesive is flowing into the tiny pores or the holes present on the surface of the substrate, and that helps into the interlocking of the two surfaces together. The irregularities of the surfaces here are responsible for adhesion of the two substrate. Last of all is the physical interaction. In this type of interaction, the adhesion takes place with the help of van der Waals forces, which is the force of attraction between all the molecules of the substrate and the adhesive or the coating. Now, this force is also known as secondary bonding force. Remember, the chemical interaction was called as the primary bonding force, and this physical interaction is called as the secondary bonding force. Since it is the van der Waals forces which are playing a role, so definitely it is ought to be a weaker interaction. Call it as an adsorption interaction.